Welcome to Classroom Teaching. I am Shekhar. Students, from today we are going to start a new concept which is related to light, a new chapter of physics, that is refraction of light. But before starting it, let us recall our knowledge. Let us see what we learned in previous standards. So, tell me what is light? That we learned in 6th, 7th standard. What is light? It is nothing but the form of electromagnetic wave, electromagnetic radiations, which creates the sensation of vision. Last year also we have the chapter Reflection of Light. So tell me, what is reflection of light? Students, normally the light, it travels in a straight line. We know that. But whenever any opaque substance comes in the line, then it falls on it and gets reflected. And due to that, the shadows can be formed. Let us see. I have a torch here. So you can easily see the shadow of the ball. And why this shadow is there? Because of the reflection of light, or because of the straight wave propagation of the light. The light, it travels in a straight line. So what is the reflection of light? We can define it that the bounce back of light from opaque substance, the bouncing back of light from the opaque substance, it is called as reflection of light. But there is one more phenomenon where the direction of the light, the direction of the propagation of light can be changed. Tell me, what happened instead of opaque substance if we take any transparent substance? Let us see. This is transparent substance. If we cannot see the shadow of this because light doesn't get reflected from it. That means, and due to that, the shadow is not formed there because light can pass through it. This is a glass. It is a transparent substance. But whenever light travels through this transparent substance, it definitely changes the direction of propagation. That means it changes its direction. And this phenomenon, we call it as refraction of light, that we are going to see here. Refraction of light. Students, many simple activities are given in this book. So, pause this video and get all the materials which are required. These materials are very simple. These are easily available at our home. What material we require? See in the textbook. We require a glass, transparent glass, then a steel glass, a 5 rupee coin, and a pencil. To perform these two activities, we require only these things. And therefore, these are easily available material. And pause the video and get it. And observe. Observation is very important. Observe what changes did you see and write down your observations in the notebook. Two activities are given. In first activity, take a pencil, fill the glass, transparent glass, with water. I did these activities and you can see these activities here. First activity, you can see it here. So, keep the pencil in the incline, which is inclined to the water surface, and observe it. Observation is very necessary. It is very important. Observe the thickness of the pencil at the surface of the water. In second activity, it is very interesting activity. Keep the 5 rupee coin at the base of the steel glass or metal glass, metal container, metal any metal pot and see that 5 rupee coin with your eye and just go behind and stop there where you are not able to see the coin. That means suppose I place the coin here. Observe the coin from here. You can see the coin, but if we go here, then you cannot see the coin due to the surface of the glass. And tell your brother or friend to fill the water slowly and keep your eye on the same place. Whenever the water is filled in it, you can see that coin. So this is our observation. So why it happens? All the changes that we observe, these are due to the refraction of light. That means due to the bending of light. Whenever the light rays, they are coming from here, from the surface of water, they bend, and due to this bending of light, we can see the coin, or we can see the changes here. Friends, one more activity is given here, and this activity, it is related to the glass slab. So we can easily find out the bending of light by using glass slab. So this bending of light, it is nothing but refraction of light. So we can define it. What is refraction of light? Whenever the light travels from one transparent medium to another transparent medium, it changes its direction of propagation, and this is nothing but it is called as refraction of light. So for getting refraction, we must require two surfaces and both are transparent. That means light can travel through it. So here water and air, two mediums are there, and whenever light travels from water to air, it bends, and this bending, it is nothing but refraction of light. So let us perform the activity of glass slab. It is very simple activity. For this activity we require a glass slab, white paper, few pins, all these material. You may don't have glass slab, but I will explain this experiment here on the board, and in this video only you can see the experiment that I have performed. Okay, so let us try this experiment, or understand this experiment first. How to perform this experiment? Okay, so suppose this is a glass slab, because if we actually use the glass slab, it is very small in size, so I cannot perform the experiment here with. So suppose this is a glass slab. What you have to do? Just draw a outline. Draw the outline. Take the glass slab away. Then by using this D, take any point here. Suppose here is the point, and make a 90-degree angle. So it is nothing but the normal at this point. So this is nothing but normal. Then again take this D, make angle of 30°. We are taking the angle of incidence. So here 90, 80, 70, 60. So it is nothing but 30-degree angle. Actually, we must know the angle of incidence or angle of refraction. Both these angles are measured with respect to this perpendicular only and not with respect to the surface. So, this is 30-degree angle. Draw a line in this way. Then, take two pins and purse it here. Again, keep this glass slab as it is and see from the other side. See from this side. And see these two pins from this side and purse two pins again such that all these four are in the same line. All these four are in the same line. So, before that, if we want to see the change in direction of the light ray, for that purpose, we first draw the incident direction. So this is direction of incident ray. If glass slab is not present, the light must travel in this direction. So this is the direction of incident ray. But if the glass slab is placed, and if we see from this side, we can say and put two pins here in such a way that they are, all these four are in the same direction. Same one, only one we can see. And draw a line in this way. So this is actual emerging ray. This is actual emerging ray. And suppose you names A and B, these are the two pins. Suppose P, Q, R and S, these are the 4 points of this glass slab. Suppose this is M, and make a perpendicular here also on this point. So for making perpendicular, I am using scale only because the lines are here. You can use D also. So it is perpendicular. Then join the actual path of the light, actual path that the light travels. So this is the actual path in which the light travels through the glass slab. So if we see, this is angle of incidence I, this is angle of refraction R, we call it as I1. Why it is I1? Because it is also the angle of incidence on this SR surface. On this surface it is angle of incidence and therefore we call it as I1. And it is angle of refraction for this surface, but the light rays coming out through the glass slab, therefore we call it as angle of emergence E. Angle of emergence E. So if we see this I, angle of incidence, it is always equal to angle of emergence. So we take it as 30 degree. So here angle of emergence must be 30 degree. And you can see that the emerging ray, it is parallel to the incident ray, only it gets shifted towards the left. Actually, we are drawing it by using what we know. That means we are not doing actually. It is just a diagram. The actual experiment you can see in this video. We perform the same experiment. So in this way, so this is 30 degree, this is 60 degree. Both these we can perform with the same way, same manner. We can perform these two activities. And if we see I have, if we want to see actually how the light ray travels, then we require a laser beam for that. Look, I have a laser beam. We can see where the laser beam it falls, but we cannot see the path of the light. Path of the light ray we cannot see. If this path, whenever this path, this path becomes visible, we learned in 9th standard the Tyndall effect. In that Tyndall effect, few small particles, if they are present in air, we call them as colloidal particles. If small particles are present in the air, they can scatter the light and then the light ray becomes visible. The ray of light, it becomes visible then. So by using very simple activity, I have a box, transparent plastic box. Make smoke in that box. I make smoke in that box. That means by using essence stick only. Then the path of the light ray becomes visible in that box. And if I keep this glass slab inside the box, I can easily see. If I use this in this way, angle 30 degree, then I can see the emergent ray here. So I can see the path of light also. For that purpose, if you have laser beam at your home, then it is very easy to see by another method also. Which is that method? Just sprinkle some powder. I use this board only. In this way, 30 degree, and if I place glass slab over here and sprinkle some powder here, then I can easily observe the angle of incidence and angle of emergence, or incident ray and emergent ray. You can see it in video, in this video. So by this experiment, we came to know that whenever light travels from one medium to another medium, it changes its path. That means the refraction of light, it takes place. And this refraction we can see for any two medium. This refraction we can see for any two medium. And this refraction takes place because the velocity of light, it is different in different media. Students, the velocity of light in air or in vacuum, we know that is 3 lakh kilometers per second. But whenever this light enters into glass, its velocity changes, because the velocity of light in glass, it is very much smaller, very much less than that of in air. So it changes. As the medium becomes denser and denser, the velocity becomes smaller and smaller, and therefore the light, it bends. The bending of light, the refraction of light, it is due to this change in velocity. So from this we get laws of refraction. In 9th standard we learned about the law of reflection. Today we are going to see the laws of refraction. Laws of refraction. Students, you might remember which we learned in 9th standard. Here also the similar laws are there. The first law, the incident ray and the refracted ray, they are always to the opposite sides of normal. 1 minute, I will draw, or you can see it here. This is incident ray and this is refracted ray, and this is refracted ray and this is normal. So incident ray and the refracted ray, they are to the opposite sides of normal. Normalच्या दोन साइडला दोन आहे. And incident ray, refracted ray and normal, they are in the same plane. So this is nothing but the first law of refraction. What is it? Incident ray and refracted ray, they are to the opposite sides of normal, and incident ray, refracted ray and normal, they are in the same plane. This is what the first law of refraction. And always remember, the incident angle of incidence, it is always taken with respect to normal. I am telling it one more time. Why? Because it is asked into the exam. They will give you 1 mark question. Student, suppose a light ray is falling on a glass slab by making angle of 60 degree with the surface of the glass. So what should be the angle of incidence? What should be the angle of incidence then? If the light ray is falling, that means incident ray is making angle of 60 degree with the glass slab, then it must make the angle 30 degree with the normal, and therefore angle of incidence is 30 degree in that case, because here it is 30 degree. If with the surface, if we calculate, it is 60 degree. Okay, so this is first law of refraction. What is second law of refraction? For a given pair of media, here in this case we are taking air and glass. For given pair of media, the angle sine of the angle I, the ratio of sine of the angle I to the sine of angle R is always constant. So this is nothing but second law of refraction. For given pair of media, the ratio of sine of the angle of incidence, to the sine of the angle of refraction is always constant. And we call this constant as refractive index. This is nothing but the refractive index. Let us calculate this refractive index. This is second law of refraction. It is also called as Snell's law. And in that Snell's law, it is given that sin I upon sin R is constant, and it is nothing but the refractive index of second medium with respect to first. So, for calculating the refractive index, we require two mediums. Refractive index of second medium is calculated with respect to first. If we take this side PQ, if the incident ray, suppose in this way, this is PQ, this is RS. Okay, if the incident ray, it is falling here, that means we take first medium, this is first medium, this is second medium. So this is nothing but air and this is glass. So if we are taking this diagram only, then we are taking the refractive index of this glass with respect to air. Refractive index of glass with respect to air. And if we calculate the refractive index with respect to vacuum, then it is called as absolute refractive index. Student, what is the definition of absolute refractive index? If we calculate the refractive index of any medium with respect to vacuum, then it is called as absolute refractive index. And some absolute refractive indices of some material are given in this table. You can see the table in your textbook. The absolute refractive index of air, it is given 1.0003. That means the refractive index of air is 1.0003. It is absolute refractive index. That means we are calculating it with respect to vacuum. That means whenever the light ray coming from sun, whenever it enters into air, definitely it bends. Why? Because it is coming from one transparent medium to another transparent medium. Vacuum is the rarer medium in that case, and air, it is somewhat denser than vacuum. So whenever it is coming from rare to dense medium, definitely it bends, and this bending, it is due to the change in velocity of light. And we can calculate the refractive index by using sin I upon sin r is equal to constant. And one more formula to calculate the refractive index, it is nothing but we can calculate with respect to vacuum also. Refractive index of, I will write in this manner, refractive index of second medium with respect to first, it is given by V1 upon V2. What is V1 and V2? Where V1 is the velocity of light in first medium and V2 is velocity of light in second medium. Second medium means of which we are calculating the refractive index. So absolute refractive index, whenever we are calculating V1, it is nothing but the velocity of light in vacuum, and which is maximum. And therefore if we see the absolute refractive index in the table, every substance, right from air, the refractive index must be more than 1. Why? Because V1 is always greater than any other V2. If we take air, the velocity of light in vacuum and in air, it is near about same, and therefore we get the refractive index of air as 1.0003 in that case. So we can calculate the refractive index of any material with respect to vacuum by using this formula, but we can use the same formula, that is V1 upon V2, for calculating the refractive index for any pair of transparent medium that we see here. Suppose this is a glass slab, suppose it is incident ray and it is refracted ray, this is normal. Okay, so we can calculate the refractive index of this glass with respect to air by the formula refractive index of glass with respect to air, not vacuum, so it is not absolute refractive index, is equal to velocity of light in air, that is V1, divided by, or V1, instead of V1 we use V air, divided by velocity of light in glass, and this is approximately 1.5 something, and it doesn't have any unit. Why? Because velocity upon velocity, units are same and therefore they cancel. So refractive index, it is a constant for given pair of material, and the refractive index of every material, it is different, or for given pair of material, for the same material, the refractive index for different colors of light of different colors, it is also different. So we will learn it in next article. One more thing, you have to keep in mind, one more thing you have to keep in mind, that if the light travels from air to glass, here instead of saying air to glass, if I say whenever the light travels from rare medium to dense medium, then it bends towards normal. Always keep in mind, whenever the light travels from rare medium to dense medium, it bends towards normal. And whenever it travels from, this is nothing but glass, so it is dense medium, dense to again air, that means rare medium, at this surface, at this RS surface, it goes away from normal. So draw a normal here, it goes away from normal. So this angle is more than this one. So whenever light travels from denser medium to rarer medium, it bends away from the normal. Whenever light travels from rarer medium to denser medium, it bends towards normal. And if the angle of incidence, it becomes 0, that means if the light is traveling in this direction, then no bending takes place, it goes through it as it is. So these are nothing but this is nothing but the refraction of light through glass slab. And you just recall the activity that we have performed right now, that a glass, steel glass, in which we keep a coin here and fill water into it. So now we must understand the reason why this becomes visible after filling the glass with water. Why it becomes visible? Because whenever the light rays, they travel from, comparatively, water is denser medium. From this denser medium to rarer medium, what happened? Suppose this is the normal to the surface. So it, whenever travels from denser to rarer medium, water to air, it bends away from normal. So this is normal, so it bends away from normal, and therefore, if we see from here, we can easily see the coin. So correlate this knowledge with the activities which we perform. Correlate this knowledge with our day-to-day experiences. If we see in swimming pool, if we place a stick in a swimming pool, and if we see from the corner, then it appears to come up. So all these are due to the refraction of light. There are so many phenomena which we experience in daily life, which depends on refraction of light. So, okay, we will stop here. What we learn in this video? First, what is refraction of light? What is it? What is it? Whenever light travels from one transparent medium to another transparent medium, it changes the direction of propagation, or it bends. It is called as refraction of light. Then we see the activity in which we perform with the glass slab activity. In that activity, we again see whenever the light travels from air to glass, it changes the direction of propagation, and therefore the emergent ray, it is definitely shifted towards the left of the incident path of the ray. Then we see the laws of refraction, two laws of refraction that we have seen. Then refractive index we have seen. Refractive index of second medium with respect to first medium is equal to velocity of light in first medium divided by velocity of light in second medium. And one more thing, if the light travels from rare medium to dense medium, here rarer and denser, these words are related with the optically rarer medium and optically denser medium. If the light ray travel from optically rarer medium to optically denser medium, it bend towards normal, normalच्या जवळ जातोय. And whenever the light travels from optically denser medium to rarer medium, it goes away from normal, normal पासून लांब जातोय. मग तुम्हाला जर एक प्रश्न विचारला, if the light travels from water to glass, in which direction it goes? Definitely it bends because both are transparent medium. Definitely it bends. In which direction it bends? It bends towards normal because glass is somewhat denser than water. And whenever it comes out from the glass, it goes away from the normal. So this is about refraction of light. So here we stop in this video, and we will see in the next video the dispersion and some natural phenomena which are related with this refraction of light. Okay, thank you.